So yeah, it's 1:28 a.m. I had previously recorded my reading on brief history. It was like okay, but I don't know. I didn't feel it that. It was good actually. It was a good read, but I was more interested in deriving the equation of aperture. So let's directly get into that, and we'll just record that later and read that later. So yeah, the main thing is this behavior. Behavior of light through aperture. This is what I call it. The behavior of light through aperture. This is interference, diffraction, and things. Okay. So previously we had some things. We knew few things. Now we know few things now. Get the sound checks in. So we have two things now. We have a plane wave solution, a spherical wave solution. A spherical wave solution. A plane wave solution and a spherical wave solution. This was like it's basically split it, right? This was the assumption. This was the main thing which led to this. Yeah, this was the main thing for this, and for this it was this thing. A naught u of r e I omega t. So ultimately this both resulted in an equation of I omega t minus k bar dot r bar. This is fine. UR equals, here also it's UR equals to A U of R, wait no, equal minus equal I of omega t minus kr by r. I need to check this, I guess. Let me just go up, right? Let me just go up. Did write few things. I even have this. I will copy this first. Yeah, this was the thing. Something like that. It's radial, so I don't know what vector in the direction of k. I don't know. So yeah, we have two solutions. Now we are powerful, right? We are powerful. Like we have so much power in our hands. Now let's go back here. I'm just going to copy this. This is my morning session, It went so bad. There was a lot of disturbance and stuff, so I just continued to do some other things. CS assignment. Yep, here. Yeah. So a general gyan would be that spherical waves are a general wave, like spherical or general. Generally, the waves travel in a spherical manner. ways, okay. At higher radii, at higher distances from source, it behaves as a plane wave. You see, a by r e power I omega t minus kr, like r tends to r is very high, and yeah, this basically can be something like perpendicular to r, something like that, and like this almost becomes a wave and stuff. Yep, so we don't use this stuff now. Wait, what? I can just paste it again and just hope GoodNotes won't crash. You can open it anyways. So yeah, this is aperture, this is observer plane, the light is coming here, incidence, and now you see we need the field over here. Okay, something like that. We need a field over here. Okay, we need a field over here. So we basically do that. We basically find field at P, U of P. Now U of P is basically superposition of all the fields on the aperture, emanating from the aperture. Yeah. Like this word emanating comes with significance from this Huygens principle. Who says that? Exact definition मुझे याद नहीं है. Classroom. Quick. 07. Wait, what? Huygens principle. Yep, Huygens principle. I just hope he wrote it here. Yep, Fresnel-Huygens principle. No, it states that each point in the aperture acts as a secondary source of radiation in the electromagnetic field of intensity to point at the surface of the plane as the radius of the cool. Yeah. In an aperture, every point behaves like a point source, emitting a spherical wave. Now these two combined to give UP is equals to integral over aperture E0 times e power I k omega t minus kr by r d psi deta. Yeah, so basically he says that the field over there is proportional to this. This. Something like that actually. Okay. One thing I was not clear about is that the origins are located here toward are located here. Which is xi and which is eta? This is xi and this is eta. Okay. I don't know how to write. X, this is x, this is y. Let me erase this down here. Let me erase this down. Oh my god. Okay, baba. This is xi, this is eta. Dude. Okay. This is the basic thing, and R is a wait, R is like the distance from there to there. Yep. It is R is distance from observer plane to zeta plane. Eta square plus z square. No. What? Okay. Assume this is z naught. Something like that. Like, let's say z only. Let's say. Okie doke. We have this thing. See, basically it is integration of that. Okay, mostly. U of p is c times integral over aperture a naught times e power I of omega t minus k r by r into d xi d eta. Okay. This is okay in the sense this was very, it is big statement, right? It's a big statement. What do you think about this? Yeah. See, this is a field. This is field. Okay, this is field. It's not a density, it is nothing. It's just field. It's pure field. We're multiplying it by an area. Why? Why? It's something like to do with the Fresnel-Huygens principle. Exactly. It's like near the aperture. Okay, near the aperture. Exactly, right? Exactly. Near the aperture, the field is kinda split. Like the field at that point is not A naught anymore. Some characteristic of A naught by R naught. A naught by R naught, and from here it begins another thing, right? So it kinda depends on the area factor. The area of the aperture, right? The area of aperture. Okay, it's just a single aperture. The field is the field is divided in the sense the field is taken and given. Right, it's just not a pure thing. It's that there is a source here, there is an aperture here, and yeah, and in an aperture it further remains right. So then it depends on the area. It depends on the area because that field is producing emanating again. So it of course depends on the area, how much light is being coming out. So what is the ground of Fresnel-Huygens principle? Fresnel-Huygens principle का grounds क्या है? It is basically it can be empirical हो सकता है. Let's search like why not. Fresnel-Huygens principle. Its principle. The weather of classes might promote wave propagation both in far-field limited waves in diffraction and also reflection state at every point on the wavefront itself the source of the spherical wavelets. Okay. I mean, okay. Wow, dude, this is like. Oof. Perfecto. अच्छा Kirchhoff fraction formula. Dude. Is it true? अच्छा. Oh my god. तो टाइप्स हो गया भाई. Is correct for matter wave section replacing time. Wave equation of the quantum mechanics is first order in time. Equation of optics is second order in time. Quantum mechanics is first order in time. Oh my god. Yeah, I guess we'll dig into that later someday. So observer plane, picture, we derive some things, we make some things, do some things, yeah. We assume Huygens principle is true. We'll dig into that. Future in classical mechanics, perhaps, I guess. Yeah, so this is like due to single thing. So if you just do it in a proportion, this must be true. This must be true, right? Okay, it must be true. Yeah, their emission, their emanating characteristics, their emanating characteristic is not that strong as is not that strong as true source. This is like the secondary source, right? Perhaps we can calculate the exact mathematical thing. Maybe, of course. So now comes the interesting part. So you basically know that at P it's the superposition of all the apertures, all the many apertures. There's no single aperture actually. There are many dots. This is very crude. Of course, this is the most basic diffraction. Of course, it will be crude. Okay. True source. Okay. So now comes the interesting part, which is how do you evaluate C? How do you evaluate C? Basically, it's like over I omega t minus kr by r d psi deta. Instead of doing it in an aperture, I mean, see, one thing is that yeah, exactly. Wait, we are putting. Wait, see, we need to evaluate this constant. We need some kind of boundary conditions. Now in this case, aperture is here, and we expect some things. Okay, what are those things? We have a radial incidence, spherical incidence. Now, assuming there is infinite aperture, the aperture is infinite. Wait, what the heck? I guess the incidence is not spherical, dude. तो पूरा गलत हो गया है. Plane waves are incident. Shit. Plane waves, like spherical waves at a higher distance from source. A clean plane waves propagating in z direction. That was the essence of it. So now you just make the aperture infinite. अब क्या होगा? ये original propagation will continue. So simple. C infinity plus infinity. It's basically an aperture. We are hypothesizing it. A e power I omega t minus kr by kr d psi equal to what? Like e power I omega t minus kz. Okay. True that. Okay. Perform the integral. I'm cynical there. But you see here, let's solve it. Okay, let's solve it. Let's solve it seriously. KZ equals to C to minus infinity to plus infinity A naught by R e power I of omega t minus KR. Wait, let's chill some. Fast, Luffy, fast, Luffy. So where was I? What am I doing now? I am finding the integral. I am reaching Sir actually. Wow, this is good. What's the point? Okay, what's the point here? Take the aperture very large.
I remember the time you were my
integral. बीटा पिक्चर का लेंथ बढ़ा दो, क्या होगा? C and N magnitude increase. You approximate it and integrate from minus infinity. It works. Same as minus 2s and reasonable. कि reasonable लगा के पूरा भी कर लो, क्या होगा? क्या होगा यार? Probably you'll get a better result. Oh, damn. Interference.